Hello, welcome back to Brandon to Cyber. Today we're going to continue where we left off at last time. Looks like we went through the complete beginner's introduction and then started some of the Linux fundamentals. We're going to continue on to the part 2 today. It has been a little bit since the last episode that I made. I've been studying for certification, so just took this exam today, so it's been kind of hectic trying to study and do all this at the same time. But last time we were at the Linux fundamentals, just kind of learning a little bit about Linux, learning some of the few commands that you can use in Linux OS, and trying to kind of figure out what can we do, how can we interact, how can we find different things inside the files. So we're going to continue on with the Linux fundamentals part 2. So just a quick introduction. Second part of the fundamental series, applying the knowledge we learned in the first installment, which we've already done. So looks like we'll be ditching the browser, blah blah blah. All of this, yeah. Okay, it's just saying that they're doing some changes to it. Accessing our Linux machine using SSH, just telling us how to start it, starting the attack box, how to connecting to it. Let's see, to the use SSH, so let's go ahead and do that. So we're going to do SSH, TryHackMe, already have it, TryHackMe, and now we're in. So, cool, we just did that. Introduction to flags and switches. So majority commands allow for arguments to be provided. They can be identified by a hyphen, certain keyword known as flags or switches. Discuss how we can identify what commands allow for these to be provided and understand what these do exactly. As per default behavior, for example, else list contents, however, hidden files are not shown. We can use flag switches to extend the behavior of commands. Using our else example, else informs that there's only one folder named folder1. So, I see these folders. Maybe it's on their thing. However, hidden files are not shown. Oh, that's on the screenshot below. Note that the contents screenshot below only examples. Okay, yeah. So they did ls, and they saw only this folder. But using the tag A argument, short for all, we now have an output with a few more lines of folders such as .hidden folder, files and folders with the dot are hidden files. So that's a great little snippet. So if you remember, we had Joplin. This was our note-taking tool, something that I've used personally in the past that I strongly recommend. And I've just kind of condensed it all down into my Linux fundamentals page. And I still have the quick links just for reference for anything like that. But the main point is that I just want to kind of combine it all. So we'll do tag A, and we'll let's get all this. We'll do like that. All right. Let's go back. So here they did ls tag A, and they saw that there is a new hidden folder because there's a dot. Commands accept these will also have a tag help option. Help is always a useful thing to put in our notes. So we'll just leave it there. That's fine. So list possible options. Can accept provide a brief description example of how to use it. So here they did ls tag help, and it shows all the different options, all the different tags, switches, flags, all that fun jazz as to what the ls command can actually use and perform. The manual page. If you remember last time we talked about man is just a manual. Basically just shows you all the information about a certain command or how to use something, so that way you can see the syntax of how it should be typed out, and then as well as how maybe that command can be constructed together with other flags as well. So here looks like they're doing the manual for the ls, the list command. So yep, great source of information for commands and applications, like I just said. Also available online as well. Let's actually get this link. Oop. So let's actually put this into our quick links page, and we can say online manual web page. Cool. So it looks like here, different things you can look for. So I can click on section 1, seeing all these different commands. See if ls is on here. Let me do the list. That's still quite a bit. As you can see, there's a lot of different things that we can look at here for the man page. Okay, explore the man page of the ls command. Let's do that. And see, this is also what it looks like here. Scroll down, seeing all the different flags we can do. Even shows a synopsis of kind of how you would run it, and tells you what the command does. Yep. What directional arrow key would we use to navigate down the manual page? Well, let's see. Looks like it's the down arrow. So I would hope it's down. Okay. What flag will we use to display the output in a human readable way? So let's see. So read. So if you didn't know, you can do a slash and then type in kind of what you want to look for. It's almost like if you do Control F for like finding or searching on a page for something specific. So here we did read. So we see it's the TAC H option up here, human readable, but you can also go through and see if there's anything else. So TAC H. Sweet. File system interaction continued. So cover some of the fundamental commands when interacting with the file system, how to list, how to find contents of folders using ls and find, and navigating using the cd or change directory. In this task, we're going to learn some more commands to interact with the file system. Cool. Creating files, moving, deleting, all that's really useful stuff. And all these different files. So I like to just take all this and we're going to paste into our notes. And this is going to be, we'll call it create, move, or delete files / folders. Oh, let me put them together. I think that's why it's not bulleting it. There you go. We'll do like that. Cool. So now we have that in our. I don't know if I can make this into a. I don't remember. It's not what I wanted. Well, it's fine. That's fine. I wonder if I could actually just. Nah, but we'll be alright. Similar to using cat, we can provide full file paths, directory 1 to know for all these commands. Oh, that's a cool little pro tip. Actually, let me add that in. And then we'll go back. Creating files and folders, touch and make dir. Creating files and folders on Linux is a simple process. We'll cover creating a file. Touch command takes exactly one argument. Name we want to give the file we create. For example, we create the file note by using touch note. So let me get out here. Touch note. And we can see we just created this file. Cool. Yep, as it's shown here. We can also make a new folder by using make dir or make a directory. Here they did make dir my directory and create a new directory. We can show this like, and there it is. Removing files and folders, we can use rm or remove. However, you need to specify the tech R, capital R specifically, switch alongside the name of the directory you wish to remove. So here they did rm note, and now it's gone. Rm tech R for my directory. So let's try that. So if we did rm to note, and it's gone. And then we do rm tech R to my folder. Oh, actually, I think that's theirs. Let me do my new directory I just created. There we go. see. I don't think the tac R was mentioned. Yeah, so let's go and copy that over too. We'll drop that here, and we'll put this for the rm command. Copy, moving the files and folders to CP and move. So copy takes 2 arguments, the name of the existing file. Let's actually copy that. That might be a good note. Well, actually, let's copy this entire line. So we'll specify here, copy command CP. It's specified that way. So looks like you need 2 arguments, the name of the existing file and the name we wish to assign to the new file when copying. Copies the entire contents of the existing file into the new file. In the screenshot below, we're copying note to note 2. So here we see CP, note, and note 2, ls. Alright, so now moving a file. Looks like moving a file takes 2 arguments, just like CP. However, rather than copying or creating a new file, MV will actually merge or modify the second file that we provide as an argument. Now you can use MV to move a file to a new folder, but you can also use MV to rename a file or folder. Okay, that's actually a pretty good little tip. Oh, good night. Can't type. Move command. MV. I'll keep doing that. Cool. And we'll go back. So, example below, we're naming the file note2 to be named note3. Note3 will now have the contents of note2. So it looks like here they copied note, the original note, to note2, and then they're going to move note2 to note3. So instead of it becoming, note, note2, note3, now it's just note and note3. And determining a file type. So what is often misleading and catching people out is making presumptions from files as to what their purpose or contents may be. Files usually have what's known as an extension to make this easier. Text files usually have an extension of .text, but unless it's not necessary. So far, the files we've used in our examples have an extension. Without knowing the context of why the file is there, we don't really know its purpose. So we can enter the file command. It takes 1 argument. For example, we use file to confirm whether or not the note file in examples is indeed a text file. So here they use file and note, and it came back saying it is ASCII text. So first question, how would you create the file name new note? So we can do a touch new note, and there we go. On the deployed machine, what is a file type of unknown 1? Okay, so here we see unknown 1. So we do file unknown 1, and it is ASCII text. So we'll go throw that back. Hold on. What? ASCII text. Oh, I was looking down here. Oops. Cool. I will move the file, my file, to the directory my folder. Move my file to my folder. What are the contexts of this file? Let's see. So ls cat my file. Remember, cat is how we look and open files. And here we see thm file system. So let's add that in. THM file system. Awesome. And continue to apply the knowledge that we've learned. Permissions 101. As we've already found out, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads us. In our previous tasks, we learned how to extend the use of commands to flexible switches. So take, for example, the ls command, and when using the tech else switch, we can see 10 columns such as in the screenshot below. However, we're only interested in the first 3 columns. So here they did ls, tech l, and h, just to see kind of what it is. I believe h, as we saw earlier, was what, human readable. We can confirm if we wanted to by doing ls help. We can scroll up here. Tag H, yep, and it was human readable. So they did that. Although intimidating, these read columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file folder can have a couple of characteristics that determine what actions are allowed and what user group has the ability to, what user group has the ability to perform the given action. So they can do read, write, or execute. Switch or using SU to switch to user 2. So here they switch users to user 2, put their password in, and instead of them being TryHackMe, they now became user 2. Let's use the schematic.pem file. In our initial screenshot at the top of this task, it has a tag indicator highlighting that is a file and then RW followed after. So let's see. Let's see if that's on here. It's not. So maybe we just reference this. And it has a tag indicator highlighting that is a file. So this right here. And then RW followed after. So this right here. These little 3 characters. This means that not only the owner of the file can read and write to this file, but cannot execute it. So if it had RWX for read, write, execute, then they could execute the file. Differences between users and groups. The great thing about links is that permissions can be so granular. While a user could technically own a file, if the permission has been set, then a group of users can also have either the same or different set of permissions to the exact same file without affecting the owner. So let's put this in real world context. System user runs a web server, must have permissions to read and write files for a web application. Companies such as web hosting companies will have to want to allow their customers to upload their own files for their website without being the web server system user, compromising the security of every other customer. So here we're going to learn about switching users. So they're using the SU command. Unless you're the root user or you're using root permissions through sudo, you require no 2 things to facilitate this transition of user accounts. User wish to switch to and their password. So let's copy that real quick. So we'll do switch user command SU. And let's bullet these 2 right here. Sweet. Let's go back. So it takes a couple switches that may be of relevance. So we can execute command once you log in or specifying a specific shell to use. It says encourage you to read the man page for SU to find out more. However, they're going to cover the TACL or TAC login switch. So by using the TACL switch to SU, we start a shell that is much more similar to the actual user logging into the system. We inherit a lot more properties of the new user, i.e. their environment variables and the likes. So here, they're using switch user to user 2, putting the password in, regular way of switching to a brand new user on the link system. When using SU to switch to user 2, our new session drops us into a previous user's home directory. So here they did SU tag L user 2, put the password in, and put the present working directory, and now they're in a brand new person's present working directory. So here, that's the main difference. So let's just copy this right here. It's good information. It's important to know that for when it comes to this, let me line these up actually, because in some cases you may want to have those environmental variables stay or be persistent, or maybe not. So depending on how you're switching users, or maybe if you're going to their using the TACL option to go to their home directory, may enable you to do some things that you may otherwise not be able to do. On a deployable machine, who's the owner of important? All right. So as we saw earlier, we can do AL. I believe they did LH, but you can see what A is, right? So it's all. So basically, we're just seeing all the files, even if they're hidden or not. Scroll back down. Let me make sure. Owner of important. So let's see. Where is important? Here it is. So the way this works is you have the owner and then the group. So user2 is the owner and it's part of the user2's group. So user2. Just to make sure we scroll back up and we can look and see, semantic. So what would the command be to switch to the user2? As we saw earlier, su, user2. Okay, so now we're going to switch over to user2 using their password of user2. I love user2. User2. Cool. And now we're still at the home of TryHackMe, but what I can do is do, like they said, TACL. And now, I'm now in their directory. I'll put the, I should go back. Oopsies. So exit. And then cat import. And then that's our flag. So thm su underscore user2. Thm su user2. Sweet. So we learned how to switch users and then also using the TACL to maintain that new session with the kind of like user2 logging in as themselves. Common directories. So this is a lot of good notes actually right here. /etc. Let's go ahead, paste that right here. And we will bold that. So /etc. This root directory is one of the most important root directories on your system, short for etc. Is a commonplace location to store system files that are used by your operating system. Example, the sudoers file highlighted in the screenshot below contains a list of the users and groups that have permission to run sudo or a set of commands as a root user. So also highlighted below are the passwd and shadow files. These files are special for Linux as they show your system stores the passwords for each user in encrypted formatting called SHA-512. So here they're in the SE folder. They did ls, and here you see shadow, passwd, sudoers, and sudoers daemon. /var, we'll copy this. This is also a really useful folder for the Linux file systems. var being short for variable data, is one of the main root files found on Linux. It stores data that is frequently accessed or written by services or applications running a system. This could be log files running services and applications are written here, /var/log, or other data that is not necessarily associated with a specific user, so your databases and other things like that. Here they listed it out. They got backups, log, op, temp, all those fun jazz. And /root. As we've seen so far with being in a Linux system, root is the king of users and just overall allowing you to do things on the Linux system. So the root folder is actually the home for the root user. Nothing really more to this folder other than just it's the home directory for root. It's worth mentioning as a logical presumption that this user would have their data in a directory such as home root by default. So here again, it's just like if we were home user2, but here this is just the root's home directory. And then /temp. So this is another root directory found on Linux, short for temporary. It's volatile and is used to store data that is only needed to be accessed once or twice. Similar to the memory in a computer, once the computer is restarted, all the contents of this folder are cleared. So it's useful for us as pen testers that any user that can write to this folder by default meaning once we have access to the machine, so it's a good place to store things like our enumeration scripts. So here they listed to delete trash, just random garbage that will be deleted. Read me. I read you. What is the directory path that we expect logs to be stored in? So, the variable log. What root directory is similar to how RAM on a computer works? Well, RAM is volatile, so that's your temp directory. Then home directory, the home directory of the root user, that is /root. And then navigate these directories on the deployed Linux machine. So here we can go to it. We can do c/var. We see all these different files. Have some temp for all the variables there as well. Lib, log, mail, also cd into, may not be root, but temp. There's a couple of things here, some private system stuff, a snap. I don't know the sudo, so I can't go to root's home directory, but overall some good information there. So conclusion, very theory heavy in this room. A lot of understanding what files and folders are allowed and how to create them, how to modify them, their permissions on the Linux system. You see, connecting using SSH, using different flags and switches, and learning about the man pages and how to look for those. Some more commands that you'll be using to interact with the file system as contents, introduction to file permissions and switching users, a paragraph of important root directories on Ubuntu Linux, install how many will use the data stored within these. This says using to go through this again once or twice to get some familiarity. And proceed to the next task. Terminate the machine. So we'll go do that real quick. And then we'll go to the next room. So Linux Fundamentals Part 3. We are cruising right along. So here we are, Linux Fundamentals Part 3. So far we got some hand-ons with some fundamental concepts and some important commands. And it's just going to show some useful utilities and applications that you're going to probably use day by day. And also going to advance your Linux foo skills by learning about automation, package management, and service application logging. So here, we're going to go ahead and start a machine, and they'll load up in the background. As you see, it takes about a good minute to get the IP address going. And then once that comes up, I'll SSH into that, and we'll continue. Alright, looks like it finally came up, so the machine is ready to go. So we will leave our SSH shell, and then we're going to go back into creating another secure shell connection to the new Linux machine. So 10.10.90.52, 10.10.90.52. Oh, yes. I think this password is also TryHackMe. Am I right? Yep, TryHackMe. Sweet. Yeah. Oh, there we go. Sweet. So now we're in the secure shell to the new VM. And we've done it. Terminal text editors. So we've only looked at store text and files using combination of echo and pipe operators, and overall it's not an efficient way to handle data when you're working with files, multiple lines and sorts. So now we're going to be looking at terminal text editors. We're going to be introducing to Nano, but you can also use Vim. Oh, looks like Vim also has a dedicated room too. So Nano. The way it works is you're going to get started by creating or editing a file by just typing in nano in the file, and replace the file name with whatever you want to type. So we will copy this line, nano. So here they did nano, my file, and now they're into that. So just to see what that looks like, this is nano, and we can type in here and say whatever we want, and we can save it if we want to. Once we press enter to execute the command, Nano will launch. As we just saw, begin entering. You can navigate using up and down arrows, starting a new line with the enter key, all that fun stuff. So it has a lot of different things you can do. You can do searching for text, copy, pasting, jump into a line number, finding out what line number you're on. You can use all these features by pressing the Control key and the corresponding letter. For example, to exit, I'm going to press Control and X, which I just did to get out of it. So Vim is a much more advanced text editor, and it's also helpful to mention. So some of Vim's benefits, besides taking a much longer time to become familiar with, includes customizable. You can do some syntax highlighting, works on all terminals where Nano may not be installed, and there's a lot of resources, such as cheats, tutorials, and sorts available to use. And again, it has a room showcasing it. So, even though it's not a whole lot of noteworthy, I feel like information is still a good note to put on there that, hey, Vim is on a Linux machine, just in case we need to figure that out later. So create a file using Nano. We can do that. Nano file hello world. Control X, save. Yep. And there's the file. Edit task 3, locating the TryHackMe homes directory using Nano. What is the flag? So if we Nano task 3, we open it up and we see THM text underscore editors. So THM text underscore editors. Cool. And then now we can click we can push Control X to escape. General use of utilities. So downloading files, wget. A very useful tool in Linux machines is wget. So of its ability to transfer files. So you can use this to download a program, a script, or even a picture. And there's multiple ways we can retrieve files. So just covering the use of wget allows us to download files from the web via HTTP, as if you were accessing the file in your browser. So we simply need to provide the address of the resource we want to download. So if you want to download a file, name myfile.txt. Assuming you do the web address, it will look like this. So they did wget, the HTTP URL link, all the way down to myfile.txt. Another good thing is using SCP. So let's see. I see what it did. So I'm going to copy all this, which is quite a bit, but it's very useful to see SCP and it works. So secure copy, or SCP, is a means of securely copying files. So unlike you're using the regular CP command to copy locally, this allows you to transfer files between two different computers using SSH. So working on a model of source, destination, SCP allows you to copy files and directories from your current system to a target system, or from the target to your system. So that we know the usernames and passwords of the users on your system and on the user on the target system, we can copy a file and see what happens. So here they're crafting the SCP command. Remember the format is just SCP source and destination. So here they're doing secure copy. They're getting this important .txt file right here. This is on the local system. They're going to hold on one sec. All right, sorry about that. And so we're back to where we left off. So again, they're doing secure copy, important.txt on the local system. The user Ubuntu, this is on the remote system. Then the remote system's IP address right here. And then the directory of the file that they want to copy. Or, the way we should store the file as, rather. So now, if we reverse this looks a little bit different, if you can see. So from here, this is sending the file to the system. This is obtaining the file onto ours. So here they're doing SCP again to their remote system, Ubuntu, their IP, and then they're going to the documents.txt, which is the name on the remote system, to creating a file called notes.txt on our system. So let's underscore this and underscore that. Yep, and then we'll do it right there. Sweet. So now serving files from your host via the web. So some of them come prepackaged with Python 3. Python is basically a lightweight, easy to use module called HTTP server. Allows you to turn your computer into a quick, easy web server to serve your own files, where they can then be downloaded using curl and wget and any other method. Python's HTTP 3 server. What was that? Oh, Python's 3 HTTP server will serve the files in a directory where you run the command, but this can be changed by providing options that can be found within the manual pages. Simply all we need to do is run Python 3 TACM http.server in the terminal to start the module. In the snippet below, we are serving from a directory called web server, which has a single name file. So let's highlight and paste this in. Python 3 making a web server. Alright, so here they did Python 3 TACM http.server. So it serves HTTP on 0.0.0.0, which means anything, which in this case is actually their actual IP address. Port 8000, so if anybody goes and tries to connect to this machine's IP address using port 8000, they will come to this HTTP page. Now they're going to use wget to download the file using the 10.10.9052, which is the VM's address, and the name of the file. Remember, because the Python 3 server is running port 8000, you need to specify this within your wget command. So here, like I said, they're going to wget HTTP, the IP of the VM, the port 8000, and then the name of the file they're trying to get. You will need to open up a new terminal, to leave the one that you have the Python 3 server in. That way the Python web server is running, and then you can use your wget to connect to it. Well, let's take a look at the snippet. So here they did wget, they got to the IP, and then they download the file. And then here they download the file, connected, and then all the transactions there that took place from the downloading. So again, you need to run wget in a terminal while keeping the terminal as running, Python 3 active. So here I can do this in a new tab. So if we do Python 3 TACM http.server, we'll do 99. Alright, so now we're having a new server here. And I'm going to create a new file, just where I'm at. Desktop, we'll do nano, right? New file.txt. And we'll say bleh. So now we have this new file, it's hosted. So now what we can do is wget http, and then what my IP address is 10.02.15, and then we'll specify 9900 and new file.txt, and then we have to also specify desktop. And here we see we now downloaded this new file from here. You can also see the connection from my IP address to getting this new file. And if we look here on the desktop, we can now see new file.1.txt.1. So now we can get rid of both. Cool. One flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file you wish to use, which is why I prefer to use updog. What's updog? And more advanced, yeah, lightweight web server. But for now, let's stick to Python. So you're connected? Yep, we are. Now use the HTTP server to start a web server in the home directory of the TryHackMe user. So here we're going to do Python 3, type m http.server, and this time we'll do 1, 2, 3, 4. Download the file onto the TryHackMe attack box. You need this in a new terminal. Okay. So let me put this onto the system, or I think it's saying it's already on the system. Let me check. Not entirely sure. Dot flag. So be, yeah, there it is. Okay, so it is already on the system. So I can start the Python server back up. Here we're gonna create a new tab. wget 10.10. What's the IP? 9052. So go back over here. 9052. 1, 2, 3, 4. Flag. And it's just .flag.text. Okay. So here we got the new file, just to make sure. You can see, oh, let me go to my, I think it's, yep, there it is, right here, flag. So we can just cat this real quick. And it is thm web, or wget underscore web server. thm wget web server. Create and download files for further player learning. So you can read the documentations on the Python 3 web server, and then as well as Control C to stop it. So we can Control C, and let's see if Python 3 has a help page. And it does. So here you can, if we scroll up to a library module, which was the http.server module, which is what allows it to run the web server. Processes 101. Processes are the programs running on your machine, managed by the kernel, and each process has an ID associated with it. This is known as PID. The PID increments for the order in which the processes start. The 60th process with a PID is 60. So to view these processes, we can use the PS command to provide a list of the running processes as our user's session and some additional information such as is SAS code, session that is running it, and how much usage time of the CPU it is using, and the name of the actual program or command that is being executed. So we'll throw this in here. And I'm going to copy this image and throw that in as well. So, excuse me. The second process, PID, has a PID of 204, and then below it is incremented 205. See, the process is run by other users, and those that don't run from a session, we need to provide aux to the PS command like so, ps aux. And then I will throw that image in as well. So now we can see that there is a total of 5 processes, and we also have the user root and some static. So 1, 2, 3, 4, 5. Another very useful command is the top command. It gives you real-time statistics about the processing running your system instead of a one-time view. These statistics will refresh every 10 seconds, but also refresh when you use the arrows keys to browse the various rows. Another great command to gain insight is via the top. So we'll take the copy. Oh, we'll copy this. So managing the processes. So we can send different signals to terminate the process or perform other ways to manage the processes. And this is correlate to exactly how cleanly the process is dealt with by the kernel. So to kill a command, we use the kill command and the associated PID that we wish to kill. So to kill PID 1337, we use kill 1337. And then down here below are different signals that we can also send to the different processes. So here they have sick term, sick kill, sick stop. So if you do sick term, now you're allowing to clean up some of the tasks. Sick kill just kills it, and then sick stop, all this is a stop or suspend. So if you notice when I do a control C or you do a control Z, you can see the difference for that. So example, if we run TryHackMe http.server, I'll do port 8000. If I do control C, it exits it. It's almost like it kills it, right? But if I do control Z, it actually stops the process. So that's using the sick stop. So how do the processes start? So they use these things called namespaces. The OS uses namespace to ultimately split up the resources available on the computer, so your CPU, RAM, priority. Think of it as splitting your computer up into slices. Process with that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Great for security as a way of isolating processes from one another. Only those that are in the same namespace will be able to see each other. We previously talked about how PID works, and this is where it comes to play. The process with the ID of 0 is a process that started when the system boots. Processes systems init on Ubuntu, such as systemd, which is used providing a way of managing a user's processes and sits in between the operating system and the user. Once the system boots and initializes, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it's controlled by systemd, but will run as its own process, although sharing the resources from it. So we're going to talk about namespaces. And paste that information there. So here we can see PID of 1 is the very first process that starts, and systemd. So getting process services start on boot. So some of these applications can start on the boot of the system we own. So web servers, database, file transfer servers, software is often critical, often told to start during the boot up of the system by administrators. So we're going to be telling the Apache web server to start Apache manually, and then telling the system to launch Apache 2 on boot. So enter the use of systemctl. This command is what allows us to interact with the systemd process /daemon. And continue with the example earlier is this is an easy to use command that takes the following formatting. So systemctl, the option that we want to run it with, and the service. So here they're running systemctl. They're going to start Apache 2. And the same if they want to stop it, they would say systemctl stop Apache 2. So we're going to use this for our notes. Start, stop. There's another option, enable and disable. There we go. So introduction to backgrounding, foregrounding. So we can run into states of either the background or the foreground. So commands that you run in your terminal, such as echo or things that will run the foreground of your terminal, as is the only command provided that's been told to run the background. Echo is a great example, as the output of echo will return to you in the foreground, but wouldn't in the background. So here they did echo hi thm in the foreground, and then they did echo hi thm in the ampersand to put in the background, which, as we can see, when they did that, it did not produce us an output to see. Let's actually copy this one. This one has a lot more information. So again, yep, after adding the ampersand operator to the command, we're just giving the ID of that go process rather than actual output. So it's great for commands such as copying files because it means that we can run the command in the background and continue with whatever we want to do. So we can do the exact same thing when executing things like scripts. So rather than relying on the AND operator, we can use a Control Z, like I mentioned earlier, on our keyboard to background a process. It is also an effective way of pausing the execution of a script or command in the example below. So see, they were saying this is going to keep looping. They could press Control Z to stop the background of this shell, or this script rather. By using Control Z, now terminal is no longer filled up with messages until we foreground it, which they're going to discuss. So here, we can see the example script from earlier, the background.sh, which they confirmed using psaux command. So then now they can bring this back to the foreground. So here they have, their user who ran it as, and the PID, and, the time and all that good information you get from the process command. And they see that, hey, it's running in the background. So you can either use Control Z or the AND operator, and we can also use FG to foreground the application. So here they did FG, and it brought it back to the foreground. Let's see. If I were to launch a process where the previous PID was 300, it would be the new process would be 301. We wanted to cleanly kill a process. This process would be what? Be sig term. Oh, sig term. Oops. There it goes. Fixed it. Locate the process running on the deployed instance. What flag is given? So let's look at it. So here's all the different processes running, but we just want to see what's actually going on here. So we see bash, python 3, ps. So what flag is given? So I don't see a flag here. So what we can do is we did the psaux. So let's see if it gives us any other flags in the text here. Oh, there it is. Really hard to see, but THM processes. So what command would we use to stop the service, my service? So it doesn't look like it just wants to kill it. So how would we stop a service? So we can do systemctl, stop, and then service name. That's a good one. Systemctl, stop my service. Perfect. What command would we use to start the same service on the boot up? So this is starting it on boot up, which is different from starting it. So we had to enable it, which would allow it whenever it comes on boot up to actually start. Starting it and stopping it is current, whereas enable and disabling is when it comes up on boot. And what command we use to bring background process? This is FG, or foreground. So now we're going to be maintaining our system using automation. So users may want to schedule certain action or tasks to take place after the system is booted. So running commands, backing up files, or launching various programs. So we're going to be talking about the cron process. More specifically, how we can interact it using cron tabs. Cron tabs is a process that is started during boot which is responsible for facilitating and managing cron jobs. Cron jobs and cron tabs. Excuse me. Cron tab is simply a special file where formatting is recognized by the cron process to execute each line step by step. It requires 6 specific values. That's a tongue twister. Actually, let me copy this line. So, we're going to drop that down. So, they have a minimum, or not minimum, a minute. So, the minute to execute, an hour to execute at, the day of the month, the day of the week, and the actual command that would be executed. So, here, there's trying to back up some files. And so, they're going to back up semantics documents every 12 hours. So, this is how that formatting will look. So, this is every 12 hours. So, we're not going to deal with the minute. So, the star here is the hour. The /12 is saying for every 12 hours. And then the rest of it doesn't matter because we're just saying every 12 hours in general. They're going to copy and recursively copy from the home semantic documents all the way down. So every single document that's in that folder. And then going to copy that to the var backups folder. Interesting feature of cron tabs is that these support the wildcard or asterisk. If we do not wish to provide a value for that specific field, we don't care what month, day, or year, only that is executed every 12 hours, we simply place an asterisk, as we see here. This can be confusing to begin with, which is why there are great resources such as the cron tab generator allows you to use a friendly application to generate this formatting, as well as the cron guru. So cron tabs can be edited using the cron tab tag key, where you can use an editor such as Nano to edit your cron tab. So here you can see same thing from earlier, and instead now they're adding some extra stuff to filter out all the extra noise from the backup, and it'll show, hey, this is going to run each of these times. And same here, this is them opening it up in Nano for them to look at and edit. So ensure connected. Yep. When will the cron tab and deployed instance of this run? So we're going to type in cron tab tag E. So at reboot, they're going to run this process. So we're going to type in reboot. Oh. But when the cron tab and deployed instance run, it said reboot. At reboot, I'm still in the shell. Let's see. Cron tabs can be edited, which would show me where it should be at reboot. Take a look at the position and the value with the appropriate column. It says at reboot. It's interesting. So did I just type it or something? Did I need the at reboot? Okay. I was like, am I going crazy? Alright. So, package management. So now we're going to be introducing some packages and software repos. So when they want to submit, developers want to submit software to a community, they will submit it to an APT repository. If approved, the programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. So when using the ls command on Ubuntu, this file serves as a gateway registry. So here they're doing etc apt ls, and here's all the different configuration daemons and all the different information for those different packages that's on that system. And as you can see here, they have some more. So here's this another, looks like software from Canonicals, their partner repository, and just some other information about it. So while operating system vendors will maintain their own repositories, you can also add community repositories. This extends the capabilities of your operating system, and it can be added using the add apt repository. So let's put that in our notes. Adding apt repositories. So managing your repositories, so adding or removing them. So normally you'd use the command apt to install them, but the apt command is part of the package management software, also known apt. Apt contains a whole suite of tools that allows us to manage packages and sources of our software and install or remove software. So one way is to add them using the add, but we're also going to walk through adding and removing a repository manually. So while you can install software through the use of package installers such as dpkg, the benefits of apt means that whenever we update our system, the repository that contains a piece of software that we add also gets checked. So that's a nice little piece there. So in the example, we're going to add the text editor subline to our Ubuntu machine as a repository. That's not part of the default Ubuntu repository. So when adding software, the integrity of what we download is guaranteed by the use of what's called GPG, New Privacy Guard keys. These keys are essentially a safety check from developers saying, here's our software. If the keys do not match up to what your system trusts and what developers use, then the software will not be downloaded. So this is a lot of steps. So let me just copy it first. And then we can go and read it. So we need to add the GPG key for the developer's subline text. So it does not have internet access, so don't worry about this. So now we have to add this key. So this is the subline key. So we're going to do wget and then the file locate or the website location and then the location of where the GPG key is, and then they're going to add it. So now then they're going to add it to their trusted list. Then they're going to add these repository to their apt sources list. So good practice is to have a separate file for every third-party repository that you're adding. So here they're going to create a file named text.list. So touch, creating a new file, name this. And the Etsy app sources.list.d. So here they went to the sources.list.d directory, then they're creating this file in it. Then they're going to use Nano or any other text editor to add and save the text repository to the creative file. So here is deb, the download link, and then the apt stable. After we added the entry, we need to update apt to recognize this new entry. This is done using apt update. And then once you're successfully updated, you can proceed to install the software using apt install subline text. So then now, after they added this key in, they said, okay, I want to download it. So they downloaded it, they added the key, they created the file for it in their sources list. So that way, whenever it goes to get updates, it will update this package. And then they're going to just go ahead, just see if there's any updates, run apt-get, and then as well as installing the subline text package. And then now, if they want, they can remove the package by doing apt repository, remove, ppa, package name, or by maintaining the file that we previously added. We can also use apt remove, software name, so apt remove subline text. This only requires you to read through the material, so that's what we did. So maintain your system and logs. So briefly touch upon log files and where they can be found. So let's just recap. So again, located in the var log directory. Files and folders contain logging information, so application services running on your system. The OS is pretty good at automatically managing these logs in a process that is known as rotating. So they highlight some logs from 3 services running on a Ubuntu machine. An Apache web server right here, logs for the failed to ban service right here, and the UFW service, which is basically a firewall, which is right here. So these services and logs are a great way in monitoring the health of your system and protecting it. Not only that, but the logs for services such as web servers contain information about every single request, allowing developers or admins to diagnose issues or investigate intruders' activity. So the 2 types of log files below that are of interest here are the access log and the error log. So you can see there is a lot of access log rotations that are created, which means that there's a lot of access attempts, and then as well as a lot of errors, which may include that maybe this was some type of attack where they're trying to brute force into this web server. And then there's logs that contains information about the OS. So this is just about rotating logs. So I want to say right here. So look for the Apache 2 logs on deployable Linux machine. So go back, cd to var log. As you can see, we have Apache 2 right here. What is the IP address of the user who visited the site? So we can go to Apache. And so the way these work is this is the oldest log and the numbers are the newest log. So let's see .1. So it looks like someone got some type of image from this machine. So what is IP of user who visited the site? Let's see. Want to say it is 10.9.232.111. 10.9.232.111. Yes. And what file did they access? Looks like catsanddogs.jpg. And dogs.jpg. And so, this is a summary. So this is the end of the Linux fundamentals module. So you should be familiar with Linux now, and overall just kind of the powers that Linux has. So we learned about text editors, general utilities, processes, package management, automation. Some other rooms and tools that we can learn is about bash scripting and regular expressions. So we can go ahead and terminate this room and continue our learning in other rooms. Oh, and there we go. Congratulations. We completed Linux Fundamentals Part 3. So we're just going to go on ahead. We're going to refresh this page. Make sure that this is turned off. Terminate. And now if we go back to our learning module and our learning path that we're in, we can now see we completed the complete beginner in Linux fundamentals. So next we're going to be learning about network exploitation basics. And we still have 6 modules left before we finish the complete beginner pathway. So look at a quick little introduction to this. Just some OSI model, encapsulation, TCP/IP model, some various networking commands, and some other cool tools and techniques. So that will be all for this episode. Hope you enjoyed. Please let me know if there's anything that I need to be doing to help make these episodes or videos better. I would definitely like that critique, and hope that you enjoy this. Hope you have a great day, and Happy New Year's.